Okay, this is lecture 3 on organic chemistry. I'm going to start with some review. Okay, so let's review some of the things we've done. First, we have the naming. Okay, so we're gonna name some of these compounds, and if there's a single bond, remember the alkanes follows the formula n carbons, and two times that plus two hydrogens. And then for the alkeals, remember alkeals have one less hydrogen, so it's CnH2n plus one. And the alkeals want to make a bond because they have that free bond left over from not having 2n plus 2. Okay? Once again, the alkanes all end in ane, alkeals end in yl, right? If there's a double bond, these are the alkenes, and they follow a formula CnH2n, two times the number of carbons. And for the triple bond, we had the alkynes. If there are n carbons, there's two times that number, minus 2. Okay, and those are called the alkynes. All right, and remember our prefixes. The prefixes go by the longest chain of carbons, which we'll review also. Okay, one carbon, two carbons, 3, 4, 5, 6, 7, 8, 9, 10. Remember, it's meth, eth, prop, bute, pent, hexa, hepta, octa, nona, and deca. Okay, so you need to learn those prefixes. Okay, so let's name these. Okay, so on the exam or on the final exam, I could say, what is the name of these compounds? Okay, so here we have N is 2. N is 2. Oopsie, come on, pen. Come on, pen. Okay, let's try this again. All right, so it's not writing. Okay, I don't know why it's not writing. All right, n is 2, and then 2 times 2 is 4, so it's n, 2n. So we know the ending is ene. And 2 carbons, me, so it's ethene. E T H ethene. Okay, here we have 5 carbons, and twice that, right, is 10 plus 2. So this is an alkane, ane ending, follows that formula. And 5 is pent, so this is pentane. Okay, here we have 6n and 12, 2n. So this is again an ene, E-N-E, and 6, the prefix is hex, so this is hexene. Okay, all right. Here we have odd, so remember, odd is always eel. Odd is eel. Odd is eel. 2n plus 1 is always an odd number. Don't forget that. All right, so we know this has an ending YL. Okay, 3, MEP, so this is propyl. Okay, stuff rubbing alcohols made of propyl alcohol. Okay, 9, 18, so that's N, 2N. So again, it's an ene. 9 is non, so this is nonene. Okay, it's not too hard. Here we have 8, and 2 times 8 is 16 plus 2, so this is an alkane. 8 is oct, so this is octane, right? Octane is what we find in gas. This is gasoline. Octane is gasoline. All right, here we have N is 10, and 2 times 10 is 20, minus 2, right, is an ine. So this has an ending Y-N-E. Okay, and 10 is dec, so this is decine. Okay. Up top, we have 4 and 9. There's odd, so I know it's going to be an eel. Right away, I know it's eel. Anyway, it's 2 times 4 is 8, plus 1 is 9. So 4 is MEPB. This is butyl. Okay. All right, here we have N is 6. 2 times 6 is 12, plus 2 is 14. So this is an ane. And 6 is hex. The prefix is hex. Okay. Okay, 7, N is 7. 2 times 7 is 14. Minus 2 is 12. So this is an ine. This must be a triple bond, right? Ine. And 7 is hept, right? So this is heptine, okay? Here, N is 10. 2 times 10 is 20. Plus 2 is 22. So this is an ane, A-N-E. And the prefix for 10 is dec. So this is decane. Okay. Here we have N is 9. And 2 times 9 is 18. So we have N and 2N. This is, again, an ene. And 9, the prefix is non. So this is nonine. Okay. And then finally, we have, I can't even, 5 and 11. That's an 11. It looks sloppy. Okay. Again, it's odd, so I know it's an eel. I know it's going to be eel because it's an odd number. All right. So 5 times 2 plus 1 is certainly alkyl. 5, the prefix is pent. So this is pentyl. Okay. So that's not the worst thing in the world. Okay. Not too bad. Okay. Now let's kind of review some of the naming, right? Remember the longest chain. Remember how we do double and triple bonds. So for example, if I have something like this, we'll do something easy. Okay, so I'll do this. This carbon has 3 bonds, so it needs 1. This carbon has 3 bonds, so it only needs 1. This guy needs 2 more. This guy needs 2 more. And this guy needs 2 more. Okay, I'll put my H's. Okay, I'll put my H's. Okay, I'll put a Br here, and I'll put a Br here. I'll put a CH3 there. All right, the rest I'll just make H's. Okay, so suppose we want to name this beast. You get this on an exam. Okay, so okay, name this. All right, the first thing, I'm telling you, the first thing I do is I notice there's a double bond. Okay, I see the double bond. So I know right away the ending is E-N-E. It's an alkene. Okay, the double bond tells me it's an alkene. Okay, now I want to see where is that double bond? What's the lowest number carbon it's on? Well, it's clear I should start from the right because that would make this carbon 1 and this carbon 2. Right, so that double bond is on carbon 2. Okay, but the total number of carbons, 1, 2, 3, 4, 5, 6. It looks like 6. Okay, I forgot to do that. So this is definitely hexene. Okay, because 6 is the longest chain. And the double bond is on carbon 2. So this would be a 2-hexene. Okay, so this would be carbon 3, carbon 4, carbon 5, carbon 6. So we must count right to left. We must count this way. Why? Because the double bond makes it counting that way. Because the double bond counting from right to left would be on carbon 2. If we counted from left to right, the double bond would be on carbon 4. This would be carbon 4 if we counted from left to right. And that's not as low a number as 2. So where the double bond is forces us to count from right to left. So now we're fixed. We have the count. We have the carbons numbered. Okay. So now we have our additions. There's a bromine. And CH3, remember, is a methyl. Remember, that's methyl. Okay, so bromine comes first, B comes before M. And where are the bromines? Well, there's a bromine on 5 and a bromine on carbon 5. So it's 5,5-dibromo. Okay, and there's 1 methyl on carbon 4. And this would be 4-methyl. 2-hexene. Okay. If there was no double bond, if these were all single bonds, okay, and it was H's and everything, then we would count from this side. This would be carbon 1 and this would be carbon 2, because then the bromines would be on 2, 2, right? Does everybody see that? So we count from left to right if there was no double bond. But since there's a double bond, we must count from right to left. We must count this way, not left to right. Okay, and the same holds true for the triple bonds. So as I mentioned previously, having double or triple bonds actually makes the naming easier because it tells you what direction to go. Whatever side, whichever direction gives you the lowest carbon for that double or triple bond to be on. Okay, so hopefully everybody's okay with that. Okay. And then we played a couple of games, right? We played games with these kind of things, right? So I did, oopsie, sorry. Okay, so let's do one or two little problems, and then I'll review some other things. Okay, so I always make these things a little crazy, right? H7, CH3, CH3, C2H5, H, CH3, CH3, H, 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 okay. I know it's tedious, I'm sorry. You know what, I'll make this a CH3 just for fun. Okay, so we have to find the longest chain. So here's where you should pause once again and see if you can find the longest chain. Okay, I'm gonna look for the longest chain myself. 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8, 9, 3, 4, 5. Okay, I think you hopefully you'll agree with me that 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's the longest chain. Okay. Hopefully I didn't make a mistake. Okay. So this is my longest chain. There's only single bonds. So we know the ending is A, N, E. So once again, if you have this on an exam, ending is A, N, E. So once again, if you have this on an exam, any answer that does not have A-N-E as an ending is wrong. No eens or eins or eels or anything else. Okay, and we just said the longest chain 3, 4, 5, 6, 7, 8, 9 was 9. So this is definitely no name. Okay, so there's my chain. Okay, let's look at the additions. Let's look at anything not attached to that red line, right? So this is a methyl. This is a methyl. This is an ethyl. I'll write the names in a second, right? This whole thing is not part of that chain. And this is not part of that chain, CH3, right? So again, this is a methyl. This is an ethyl. Excuse me. And then we have to list them alphabetically and see which direction to go. This is a methyl. This is a methyl. And what is this? C3, right? H7, right? 3 is propyl. So this is a propyl. Okay. So if we list them alphabetically, right, we have ethyl, then would come methyl, and then comes propyl. Okay, now we have to determine which direction are we going to go in. If we start from the bottom, okay, I'll do this in black. Okay, we start from the bottom. This is carbon 3. then this would be carbon 4, this would be carbon 5, this would be carbon 6, carbon 7, carbon 8, and carbon 9, right? So we'd have the ethyl would be on a 5. So let's do bottom to top here. Bottom, because I'm not sure. I have to work these out too. Bottom to top. Okay, so we're going to go from there. That's in black. All right. So remember, here's ethyl. Ethyl is on carbon 5. Black 5. Okay. So we have a 5 ethyl. Okay. Now we need the methyls, right? So there's a methyl on 4, a methyl on 5, and a methyl on 7. So we have 4, 5, 7. 4, 5, 7. And so that's trimethyl. Okay. And then finally, we have the propyl, and the propyl is here, and it's on carbon 6. And then we have a 6 propyl. And then we said this was nonane. Okay, so that's the bottom to top. All right. All right, so let me pick a different color. I'll use this this color. Now we're going to do top to bottom. Top to bottom. Let's see what we get. Okay. So with this pink color, that means this becomes carbon 1, this becomes carbon 2, this becomes carbon 3, this is carbon 4, this is again carbon 5, and this would be carbon 6. Okay, so let's go. So where's the ethyl? Looks like the ethyl's on carbon 5, so we have 5 ethyl. Same as before, that's good. All right, now, where are the methyls? Well, there's a methyl on 3, there's a methyl on carbon 5, and there's a methyl on carbon 6, and there's our trimethyl. Okay, and then finally, the propyl is on carbon, pink carbon, right? That's carbon 4. This would be a 4 propyl. Nonane. Okay, so there's our top to bottom. So we have 5 ethyl in the bottom to the top. 4, 5, 7, 3, 5, 6, and 4. Oh, it's clear that this is the answer. So we should go top to bottom. Okay? It gives lower numbers than the bottom to top. So we should go top to bottom. Okay? It gives lower numbers than the bottom to top. Okay? Again, for me, sometimes it's not so obvious. I try not to make them too cryptic, okay? I try, but when I make them up off the top of my head, sometimes they're, not so obvious. Okay, so hopefully you can review this and see it. All right, let's do one with a double bond or something, okay? Remember, the double bond, if there's a double or a triple bond, they must be part of the longest chain, okay? Uh-huh. C3H7. Sorry. All right, I'm thinking it out in advance. Let's see, that's 2, 3, 4, 2, 3, 4. Good. I want to make sure I have the right number of bonds and everything connected. Remember, carbon must make 4 bonds. All right, so we see there's a double bond in this thing. So again, we know that the ending is going to be ENE. It's an alkene because of the double bond. Okay. Next, we have to find the longest chain. So once again, you pause and try to find the longest chain. I think I see it. 5, 6, 9, 5, 6, 7, 8, 9. Okay, I got it. I got what I wanted. Okay, 5, 6. We have to get that double bond in there. D da D, D da D, da, and da. I believe 5, 6, 7, 8, 9, 10. So I believe this is decane. Okay, and then the question is, which way do we count? Well, if I count from this carbon, that would be 1. This would be 2, carbon 3, carbon 4. Okay, if I count from the bottom, this is carbon 5. That would be carbon 6. So clearly, we need to count from left to right and then down. Okay, so that means this would be carbon 1, this would be carbon 2, this would be carbon 3, this would be carbon 4, this would be carbon 5. Okay, so where is the double bond? Well, the double bond is on carbon 4. It's on this carbon. Okay, so this is a 4-decene. Okay, so now we don't have to worry about, picking which direction, because the double bond going from top to bottom gave a lower number 4 than if we went from bottom to top, which would be a 5. Okay, so now we look at the additions. Okay, so here we have a C3H7, C3MEP. This is propyl. Okay, oh, there's our old friend methyl. Okay, anything else? Oh, yeah, we have this thing. Ooh, right here. Okay, this stuff's connected to carbon number 4. And this is what? This is a C2H5. C2H5. Well, that's our old friend ethyl. So alphabetically, we have again ethyl, methyl, and then we have to put our propyl. But we have the numbering down because the double bond told us which way to count. So this makes this easy. So first of all, where's the ethyl? The ethyl is on carbon 4, right? The ethyl is on carbon 4. So this is a 4 ethyl. Next, we look at the methyl. Well, the methyl is on carbon 3. There it is. There's the methyl. So we have a 3 methyl. And then finally, where's the propyl? The propyl looks like it's on carbon 5, right? 1, 2, 3, 4, 5. Yes. So it's a 5 propyl. Okay. So this compound then, putting everything together, is a 4 ethyl, 3 methyl, 5 propyl, 4-decene. You must say 4-decene because that tells you, right, where that double bond is. That makes it an ene. This tells you which carbon the double bond is, okay? And once you establish where the double bond is, that's the way you count, okay? Whatever direction gives you the lowest number for the carbon that the double bond is attached to. That's the way you must count. Doesn't matter where everything else is, you count using that scheme. Okay. So there's some of that practice. Now what I'd like to do is show you a couple of simple things. Not simple, nothing simple. I didn't mean to say that. Remember if we had, let's do this. 1, 2, 3, 4, 5, 6, okay? So we know right away it's a hex. I see only single bonds. So whatever this is a hexane, right? A-N-E. Single bonds, I see only single bonds. So whatever this is a hexane, right? A-N-E. Single bonds, ane, and 6 carbons, hex. Okay? H, 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 H. Sorry, I'm going so slow, but I want to be very careful with you, okay? And some students have found some errors on my earlier ones. I apologize. I wish I was perfect, but I'm far from perfect. But I'm very proud when you find my errors. I think it's absolutely fantastic, okay? So again, we know this is hexane, no tricks. And yeah, the formula is C6H, 2 times that plus 2 should be H14, no tricks. Now remember our compact form, okay? So I'm going to do this in a different color, okay? So remember, at the end here, I have a CH3. We have a CH3. Then we have a CH2. 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 And then we have on the end a CH3. Okay. And remember, sometimes I'm going to give you this, and then we have to unpack it to figure out what the molecule is, because to me, it's not so obvious when we do this. Okay, that's a 2. Sorry, that's a 2. Okay, these are all CH2s. Okay, now, same thing. Well, not the same thing. Okay, let me show you this one. Okay, let's just do something like this. 1, 2, 3. I'm going to put a double bond there. 4, 5, 6, 7. All right, whatever. Okay, so now let's fill this out. I see a double bond, so I know it's an ene, right? This carbon has 3 bonds already, so it only needs 1. This carbon has 3 bonds already, so it only needs 1. This needs 2 more, and this needs 3 more to make 4, right? Carbon makes 4 bonds, okay? Okay. H, 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 okay? H, oh, sorry, so tedious. All right, so now let's look at this guy, okay? So again, we know the ending is ENE because of the double bond. Where is the double bond? Well, if I count from left to right, that's carbon 1, 2, 3. If I count from the right to left, 1, 2, 3, 4. So we're going to count this way. Not that it matters. Okay, so it goes this way. So this is definitely a, and what did I say? The longest chain was 3, 6, 7. So this was heptene. 7 is hept. Double bond is ene. And we just said the double bond was on 3. So this is a 3 heptene. Absolutely no tricks. No tricks. Okay. So now let's see what we have. Okay. So now we're going to look at this guy. Here we have, what do we have? Oops, come on, pen. Okay. So once again, at the end here, we have a CH3. This guy is a CH2. This guy is just a CH. There's only one H there. This guy is a CH. Okay. And then we have CH2, a CH2, and then finally at the end, our old friend CH3. Okay, so I see this kind of crazy characteristic, CH. Maybe that's a clue that there's a double bond. Okay, so I want you to try to find any patterns. Okay, let's do another one with a triple bond and see what we get. Okay, let's do a triple bond and see what we get. All right. Let's do a triple bond and see what we get. All right. Oops. Okay, so here we go. I'll do this. Let's see. 1, 2, 3. Put a triple bond. All right, I'll do this. Okay, so now let's put our H's. This needs 2, this needs 2, this needs 2. Now this guy right here, right? He's already has 3 bonds on the left and 1 bond on the right. So we're not going to put anything else there, right? It doesn't need any more bonds. It's already making 4 bonds. Okay, so we go to this guy, needs 2 more, and the guy on the end needs 3 more to make 4. Okay, now I'll just put H's in everywhere. Okie doke. Now I see the triple bonds, so I know, right? We know that the ending is YNE. It's an alkyne. Triple bond, YNE, right? YNE. H, almost there, okay? I know, again, my H's look like 4s. All right. Okay, so now we said it's definitely, right, an YNE, an alkyne, because of that triple bond. Now, what's the longest chain? 3, 4, 5, 6, 7, 8, 9. Is that 9? 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, it's no 9. Okay. Now it's clear. I think it's clear that this triple bond is closest to the left side. So this would be carbon 1, carbon 2, carbon 3, right? And then, of course, this would be 4, 5. If we had other additions, then we could name them 7, 8, 9. Okay, so it's on carbon 3. So this is a 3, no 9. Okay, no tricks. No tricks. Okay, so now what we want to do is we're going to condense it. So let's see. Okay, so at the end, here we go. Here we have a CH3. Then we have the CH2. Right? That's that guy. Then we have a C. And then we have a C. Ooh. Then what do we have? We have a CH2. Then we have a CH2. Then we have a CH2. And then we have another CH2. And then finally at the end, our old friend CH3, this methyl looking guy, right? CH3. Right? So this is the condensed form of that beast, right? Notice, maybe you'll see this, you have a couple of C's in a row. Okay. What do I have? CH3. Oh, I forgot the 2 here. CH2. Sorry, this is a CH2. I'm sure you caught me on that one, right? And we have this CC together, and then we have the CH2, right? Okay, so maybe this tips us off that there's a triple bond. Once again, I want you to try to find patterns on your own without me telling you everything. Okay, you figure things out. Okie doke. So let's do some practice. Okay, let me do some examples and see if we can do it together. Try to untangle. Now, once again, I'll write the tangled mess, and then we'll try to untangle it. All right, so let's see. So CH3, CH2, CH, CH3, C, CH3, C2H5, CH2, CH2, and CH3. Okay, this is a 3 here. Sorry, not that clear. Okay, so we want to figure out what this is. My 3s are very small for some reason. All right, my 2s aren't so great either. All right, so hopefully you can read this stuff. Okay, so here's where you should pause and see if you can unwind it before I do. Okay, so here I go. I'm going to make an attempt to do this and see if you follow. So here's my CH3. Okay, so I took care of this guy. All right, then I've got a CH2, C with an H and an H. There's my CH2. Then I have a C and an H. Then what? Well, now I have a CH3. That methyl group, you see, right? And now I have a C. And then I've got a CH3. And I've got a C2, oopsie, C2, H5. Okay. Then I have a CH2, CH2. Oh, not H2, H and an H, sorry. There's my CH2, there's another CH2. There's a C, H, and an H. And then finally, we top it off with the CH3. All right, now we can name it, right? Well, let's count the longest chain, okay? Let's count the longest chain, okay? What do we have? We have 1, 2, 3, 4, 5, 6, 7. So I think this is definitely heptane. Now, which way do we count? Well, this is a methyl. This is an ethyl. This is a methyl. Okay, and if we count left to right, 1, 2, 3, 4. If we count right to left, 1, 2, 3, 4. Right? But you see, this would be 4. This would be carbon 4. But if I count this way, this would be carbon 3, carbon 2, carbon 1. So I'm going to count this way because this guy will give me a lower number. Okay. So what do we have? We have a 4-ethyl. And then we've got a 3,4 dimethyl. Heptane. Okay, I hope you got the same result, and I'm hoping that I'm correct too. Okay, so 4-ethyl, 3,4 dimethyl, heptane. Okay, all right, let's do another one. We'll stay close to this so we can kind of find the pattern. Okay, so here we go. CH3, CH, CH3, CH, CH3, CH, CH3, sorry, my 3s are a little cryptic. I'm sorry about that. CH2 and CH3. Okay, so we want to know what this is. So once again, you should pause and you should try to untangle it before I do, right? And then we'll see if we agree. Okay, so here we go. I'm going to do the CH3. There's my CH3. Now I have a C and an H. So there's my C. Come on, C. And an H. Again, doesn't matter. And now I have a CH3 attached to that. CH3. Now I have a C. I have an H. And I have an H. And I've got another CH3. There's another methyl, right? Now what do we have? We have a C and an H, same guy again, right? C, H, and again, CH3. CH3. Now I have our CH2, H, and H. And then finally, our CH3 at the end, C, H, H, H. Once again, we notice there's only single bonds, so the ending is ANE. Anything that's not ANE is incorrect. Okay, the longest chain, 1, 2, 3, 4, 5, 6. It looks like it's a hexane. Okay, and then we see, of course, we see that we have the methyls, right? So there's a methyl. Here's a methyl. And here's a methyl. Right? So if I count left to right, this would be carbon 1, carbon 2, carbon 3, carbon 4. If I counted right to left, this would be carbon 3, carbon 4, carbon 5. So I'm counting definitely left to right. Right? So it looks like a 2, 3, 4 trimethylhexane. I hope you all got that. 2, 3, 4 trimethylhexane. Okay. All right, let's go on. Let's do some more. Okay. So let's look at another one. Here we go. CH3, CH2. I'm sorry again about these threes. They're just really bad. CH, C2H5. Now I'm making them big, huh? CH, CH3, and CH3. Okay, so again, why don't you pause this and see if you can do it before I do it. And then hopefully we'll arrive at the same answer. All right, so here we go. There's my CH3. Okay, now we have a CH2. Good. Then what do we have? We have a C. We have an H. Now we have this C2H5, this ethyl group, C2H5. Okay. Then we've got a C. We've got an H. And now we've got a CH3. There's a methyl CH3. And then finally, we have a CH3. Once again, all single bonds. It's an ane. Longest chain, 1, 2. Oh, I'm sorry. I did CH3 in my head, but I'll draw this out just so you can see it, okay? Sorry. Brain fart for old man. Okay. All right, so 1, 2, 3, 4, 5. So this looks definitely like pentane. Okay, and single bonds, it's ane. Now we have to see what are the, okay, and single bonds, it's ane. Now we have to see what are the additions. Oh, well, the additions are pretty easy, right? Because there is our ethyl. And here is our methyl. If we count left to right, this would be carbon 1, 2, it would be 3 ethyl, 4 methyl. But if we count right to left, what do we get? We get a 3 ethyl, 2 methyl. So we're going to count left to right. I think that makes more sense. So we have a 3 ethyl. That gives a lower number than counting left to right. 3 ethyl, 2 methyl. Pentane. So again, I hope you got the same answer. I hope you were able to figure this one out. Okay, let's go on. I'll do some different examples now. Okay, so let's see if we can follow this one. All right, here we go. Ready? All right, here we go. CH3. All right, CH. CH3. CH. C. Oops, that's a C. And then we have C2H5. CH. CH3. CH2. And then we have CH3. Okay, so we want to figure this out. Again, you should pause and see if you can unwind this before I try to do it. Okay, and hopefully we will arrive at the same answer. All right, so here we go. CH3. Okay, so I took care of this guy. Okay. Then what do we have? We have a C with an H, a C with an H. Doesn't matter top or bottom for us, okay? C with an H, and then we have a CH3, okay? There's that methyl, okay? So we took care of that. Now we have a C with an H, right? Then what? Now we have another C, right? And then we've got a C with the H. Now we've got this C. Now we've got a C2H5. Okay, and we've got a CH and a CH3. All right, and we have a CH2. And then finally, we have the CH3. But something's wrong, you'll see. Okay, so I put everything in. Now something's wrong. Remember, carbon makes 4 bonds. Okay, now I'm going to do, I'll do green for this, okay? Let's look, excuse me, at this carbon. Did I did C2H5? Yeah. So this carbon only has 3 bonds. See, 1, 2, 3. This carbon only has 3 bonds. 1, 2, 3. So the answer is we need a double bond here. Now each of those carbons are making a double bond. So now there's a double bond. So if there's a double bond, we know the ending is an alkene, has to be ENE. Okay, now where's the double bond? Well, if I count left to right, that's carbon 1, 2, 3. If I count from the right to left, it would be carbon 4. So we're definitely counting this way. Okay, 1, 2, this would be carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, right? So it's definitely a heptene. And the double bond we said was on carbon 3. And now we have here we have a methyl, and we have an ethyl. Remember, nothing we can do now because of where the double bond is. We must count in this direction, and all the things are already numbered. And here's a methyl. The double bond is we must count in this direction, and all the things are already numbered. And here's a methyl. Okay, so the ethyl is on carbon 4, so it's a 4-ethyl. And now what do we have? We have a 2,5 dimethyl. 2,5 dimethyl. And that's a 3-heptene. Okay, so that double bond has to be there because every carbon must make 4 bonds. Carbon must make 4 bonds. Okay, let's do some more. Shall we do some more? Yes, we'll do a little more practice. Okay, let's look at this one. Here we go. CH3, CH2, okay. CC, C, CH3, CH3, CCC. Okay, so again, we want to try to name this. So pause and see if you can figure out what this is as I try to unwind it. Okay, so here we go. There's my CH3. Okay, and here's my CH2. So far, so good. Now here's a C. Now I have a CH3 and a CH3. So CH3, methyl, and a methyl there. Okay. Now what do we have? We have a C. Then we've got another C. Then we've got a CH3. Now remember, carbon must make 4 bonds, right? But this carbon, and this carbon, something wrong, maybe 3 more bonds. Okay, well, if I do this, now there's a triple bond, 3 and 1 is 4, 3 and 1 is 4. Now it's okay. So now I see this triple bond. So we know the ending is Y and E because there's a triple bond. Okay, the longest 1, 2, 3, 4, 5, 6. This looks like, oh, did I? Yeah, hexine. Okay, hexine. Now, where's the triple bond? Well, I think we start here. Carbon 1 and carbon 2. So this is definitely a 2-hexine. Okay, that means this is carbon 3 and this is carbon 4. So it looks like a 4, 4. Remember CH3 here on carbon 4. This is a methyl. There's another methyl. So this is a 4,4-dimethyl. 2-hexine. Remember the 2. The 2 is because the triple bond is on carbon 2. Okay. Let's do another one. We'll do 1 or 2 more. Okay. Let's look at this. CH3, H3, CH, CH3, CCC. Oh, there's that CCC again. Okay, so again, we want to name this beast, so you should pause and do your best shot at trying to name this. Okay, so I will do it now. All right, so here's a C, H, H, H. Okay, and we have a C and an H, C, H, and then there's a CH3. Sometimes my C's look a little anemic, right? Then we have a CCC. So here's a C, and then we have a CH3. And then we have a CH3. Sorry, that C also looks a little sick. So once again, these carbons aren't making triple bonds, are they? So 4 bonds. So if I put a triple bond here, now there's 1 and 3 is 4, 3 and 1 is 4. So everybody now makes 4 bonds. So again, the ending is YNE. Because of the triple bond, it's an ine, right? And if we count the number of carbons, it looks like a pentyne, 5 carbons. Okay, and I think we count this way, right to left, because that would make this carbon 1 and carbon 2, so that gives a lower number. So this would be a 2 pentyne. And what do we have? Well, we have this single addition, this methyl here, and the methyl is on carbon 4, right? Because we have to keep counting like that. So this would be a 4 methyl 2 pentyne, 4 methyl 2 pentyne. Okay. All right, let me give you 1 or 2 more pictures, and then I want to talk about something else. Okay, let's see if we can do this one. C H H H. Good. Okay, now we have here, and we've got a C, and I've got a C2 H5. Okay. Now I've got a double bond here, and I have a C. Okay. And I've got a C, and this has an H here. Okay. And this 1, 2, 3, 4. Good. I got to count, right? And then this C has a CH3. And here we've got a C, a CH3. And here we've got a CH3. And here we've got an H. And then we go down here. I'll make this a little longer, okay? C, a C2H5, C2H5, and a C4H9. All right. All right, so here's where you have to find. Well, first of all, we see there's a double bond. So we know that the ending is ENE, right? It's an alkene. Okay, so on the exam, any choice that's not ENE ending is wrong because this has a double bond. Now you find the longest chain. Okay, you see if you can find the longest chain. I think I found it, so I'm going to do it. So you pause and then you find the longest chain and see if we agree. Remember, you must get the double bond in that longest chain. Okay. Okay, here's my longest chain. I think it's decene. Okay. I think it's decene. So where is that double bond? Well, I believe if we start counting with this, that would be carbon 2. This would be carbon 3. Sorry, this would be carbon 4. This would be carbon 5. This would be carbon 6. Okay, so now let's look. Anything not part of that chain is an addition, right? So what do we have here? We have here a CH3. So there's a methyl, CH3. That's methyl. Good. What else? Well, this is a CH3. I know it's not clear. That's a 3, right? So this is a methyl. That's not part of the chain. This whole thing is not part of the chain. What is this? Well, that's 1, 2, 3, right? So this is a propyl. Okay. This is not part of the chain. This is ethyl. And this is not part of the chain either, is it? That's another ethyl. Okay. So again, we have an ethyl comes first. Then we'd put our methyl. And then finally, we put the propyl. This is alphabetical order, right? So now we have the double bond told us which direction that we need to count from. So now it's easy. Let's just see. Where's the ethyl? The ethyl is here on carbon 6. And there's another carbon, ethyl on carbon 6. And that's it, carbon 6. And there's another carbon, ethyl on carbon 6. And that's it. All right. So we have a 6,6 diethyl. 6, 6, because there's 2 of them, diethyl. Remember, the double bond makes us count from top to bottom. Okay, now comes the methyl. Well, where's the methyl? There's a methyl on carbon 3. Okay, there's a methyl. And there's a methyl on carbon 5. And it looks like a 3,5 dimethyl. Dimethyl. And then finally, we have our propyl. What is that propyl? Here's the propyl. The propyl is on carbon 5. So this would be a 5 propyl. Okay, so this molecule, hopefully you agree, is definitely an ene because of the double bond. My longest chain is 10, so it's decene. Oops, I forgot to call it. Where's the double bond? Well, you got to tell me where the double bond. The double bond we said was on carbon 3, so this is wrong right now. So this is a 3 decene. I got to tell me where that triple bond is. The double bond is. I keep saying triple. Okay, so you got to say where the double bond is, and that's on carbon 3. So this is a 3 decene. Okay, and then we have 6,6 diethyl, 3,5 dimethyl, 5 propyl, 3 decene. Okay, wow, that's a mouthful. All right, that's a lot to say. All right, but it's not too bad. Okay. Okay. So let's see what we'll do next. All right. Let me talk about the aromatics. Okay. So now I want to talk about aromatics. Aromatics. Okay. Now, if something has an aroma, you know what the word aroma is, right? Aroma, the word aroma means smell. So the aromatics have smells, okay? The aromatics will have smells. So perfumes and things like that, of course, would be made of these, okay? So here's what I'm going to do. I'm going to draw, not the usual chain, but I'm going to draw something like this. So everybody watch. 3, 4, 5. It's a little crooked, but that's okay, okay? Now I'm drawing this little polygon, okay? And at each corner, I'm going to be very specific as I go along, okay? At each corner is a carbon. So I'm going to put a carbon there, a carbon there, a carbon there. Oopsie, a carbon here, a carbon, and a carbon. Okay? It's carbon. Now, we know that carbon wants to make 4 bonds, but each of these carbons is only making 2 bonds. So now what I'm going to do is I'm going to attach a hydrogen to every one here, a hydrogen. Okay. Now, if we look at this, after I finish, every carbon now, if you look at any of them, is only making 3 bonds, right? Each carbon makes a bond with 2 other carbons and then with 1 hydrogen. So it's only making 3 bonds. It's not happy. It wants to make 4 bonds. So what we're going to do is, watch this. What I'm going to do is I'm going to make a double bond like this. Make that a double bond. I'm going to make this a double bond. Oops, double bond. I'm going to make this a double bond. Okay, so these are double bonds. So now this carbon makes 2, 3, 4. This carbon makes 2, 3, 4. So they all now make 4 bonds. So if we count the number of carbons, we have C6. If we count the number of hydrogens, we have H6. This does not follow any of our formulas. Does not follow any of our formulas. Does not follow any of our formulas. Any of our formulae, we'll say it correctly, right? And we had the formulae for the alkanes, the eels, the enes, and the ines, right? And this does not follow. C6H6 is a mystery, okay? Now I'm going to redraw this picture right next to this, and I want you to watch. So I'm going to try to do it again. 1, 2, 3, 4, 5, 6. Okay, I'm going to put a little thing here so we can, oopsie, sorry, a little sloppy. Okay, same exact picture, right? At every corner, this is a carbon, a carbon, a carbon. See? Carbons everywhere, 6 carbons. Now I'm going to put the hydrogens. You say, Professor, why are you redrawing this? You'll see in 1 second. Okay. H, H, okay. H, H, H. Okay. Once again, we need the double bonds, right? Because this thing, each carbon is not making 4 bonds. But now, watch what I'm going to do. I'm going to put a double bond here. And I'm going to put a double bond here. And I'm going to put a double bond here. Okay, I'm going to fix up that first one because it really does look a little ugly with these lines I drew for the double bonds. Okay, a little sloppy. Okay, so here was a double bond. And here was a double bond. Okay, now what's the difference between these two? The answer is there is no difference. What happens is, if you look, that it looks like the double bond is actually going around this ring. Okay, so in one instant, it's what I have on the left. The next instant, it's down here. Okay, and then it moves around, it circles around. So what people do is, instead of writing these two things, and what happens is, this structure, by the way, this is called benzene. C6H6 is benzene. And this is a ring structure, so we'll call it a benzene ring. Okay, and what happens is the double bonds goes between these two states, okay, and we call that a resonance. It resonates, resonance. So the double bond moves all around, keeps moving around. So one way of we write this, okay, is if you see this, right? They don't draw the hydrogens, and what they do is they draw a circle in the middle. Sometimes there's an arrow. Okay, sometimes, but usually we'll draw this. Okay, this is benzene, C6H6. And the circle just means that the double bonds that we have here and the double bonds there are just resonating around, like I have here in the circle, going around in the circle. So this is benzene. Remember, at every corner is a H, right? This is benzene. Right? At every corner, there's a hydrogen that we're not drawing, okay? There's a hydrogen coming out, okay? So this is called benzene, and it's an aromatic. Well, what do we do with this stuff? What do we do with this crap? I'm going to show you, okay? What we're going to do first is what's called, it's very, very straightforward, single substituted benzene. Substituted substituted benzene. What does that mean? It means we replace, oh, I don't know. I'm losing it here. Okay. Benzene. Okay, so what we're going to replace one of the hydrogens. Replace one hydrogen. Hydrogen. Okay, so watch what I'm going to do. So here's my benzene. That's benzene. That's C6H6. Now I'm going to put a bromine here. I don't care what I put. I put a bromine. So this would be called bromobenzene. Oh, that's easy. Isn't that easy? Now notice it doesn't matter where I put it. If I have only one bromine, every corner is the same. So I could have the bromine here. This is also bromobenzene. And if I had it here, also bromobenzene. Oops. Bromobenzene. They're all the same. It doesn't matter where you put it when you have one substitution. Okay, so if I had this, Cl, that would be chloro. Cl, that would be chlorobenzene. Okay. What if I had, again, doesn't matter if you have one substitution, doesn't matter where I put it. Suppose I had C2H5. Well, this is ethyl, so this would be called ethylbenzene. Again, we're sticking with the single substituted now. Okay. Let's do a couple more single substituted. See, it's not bad. Not bad at all. Okay. Again, it doesn't matter where I put it. If there's one substitution, it doesn't matter. So suppose I have C9H19. Well, what the heck is C9? Well, it's odd. It's an eel. This is nonil. So this would be nonil benzene. Okay. I think you get the hang of this, right? And if I had C6H13, this is hexylbenzene. And if I had, again, doesn't matter where I'm putting this, C5H11. Well, that's pentylbenzene. Not dental. It looks like dental. It's not dental. Benzene. Okay. And if I had, I'll do a different color for this one. Excuse me. Once again, one substitution, doesn't matter where I put it. If I put CH3, well, you guys are experts on this, right? So this is methyl benzene. But methylbenzene has another name also. So watch this. You've heard of this, even though you don't know you heard. This is called toluene. Remember when we did miscibility? If I'm spelling it right. All right, whatever, toluene. Anyway, toluene. I don't think there's an O in it, okay? Toluene. Okay? So another name for methylbenzene is toluene. Okay? So single substituted things are very, very simple, right? They're very straightforward. Okay? Da, 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 da. If I put an F up there, then this is fluorobenzene. Okay? Very good. Easy. So that's monosubstituted, right? One or monosubstituted benzene. Benzene. Okay, so we did mono. Guess what? We're going to do dies, right? Two substitutions. So we're going to do di-substituted. I'll call it di-substituted benzene. Substituted benzene. Okay, remember benzene is C6H6, and it's an aromatic. Now, okay, so let's just say I put bromine for now. Okay, so watch. Suppose I put a bromine like this, and I put a bromine like this. Okay, and now let's do it again. And I put a bromine like this. Okay, and now let's do it again. Put a bromine there, and let's say I put a bromine here. Okay, now let's do another one. Let's keep that bromine there, and let's put the bromine here. All of these are dibromobenzene. Dibromo. Why? Because there's two bromines. Dibromobenzene. But they're different. Why are they different? They're different because of the relative position of the bromines. Here, the bromines are next to each other. Next to each other. Okay, so what we'd call this, we could call this 1,2-dibromobenzene. Dibromobenzene. Okay, if you skip a bond, see, we're skipping a bond. If we skip a bond, skip a site, I'll say, one site, right? Then this would be called 1,3-dibromo. Doesn't matter which one you call 1 and which one you call 3, right? Because they're equal. Dibromobenzene. And now you're so smart that you can figure out this one. You see we have one here. Skip 1, skip 2 sites. If you skip 2 sites, of course, this would be called 1,4-dibromobenzene. Okay. Now they also have another name. Okay, and sometimes we use these interchangeably. So I'm going to tell you when they're next to each other. Right. This is case 1. This is case 2 when you skip 1 site, and this is case 3 when you skip 2 sites. Okay. When you skip 1 site, this is called ortho. Okay. So in other words, this would be ortho dibromobenzene. Ortho means you just skip a site. Okay? This is called meta. Okay? So this thing would be called meta dibromobenzene. And then finally, this is called, when you skip two sites, this is called para. I'll put these in quotes, okay? So this final one would be para dibromobenzene. So I'm going to do some examples. We'll do some examples. So we could either name them 1,2 dibromobenzene or ortho dibromobenzene. We can name it 1,3 dibromobenzene or meta dibromobenzene, equal. And we could name the last one 1,4 dibromobenzene, or we could name it para dibromobenzene. Okay. And then if we're listing different elements, of course, everything goes alphabetical. So watch this. Okay. So I'm going to do an example or two. Simple, straightforward, not simple. I keep saying simple. I don't mean to imply that. Okay. So there's my benzene. Okay. And let's see here. I don't mean to imply that. Okay. So there's my benzene. Okay. And let's see here. Suppose I put C2H5. And suppose here I put a C6H13. All right, well, let's name them first. Right? We know what the names of these things are, right? So this is hexyl. And this is ethyl. So we know ethyl comes first, right? This E comes before H in the alphabet. So that means this would be carbon 1. So therefore, what we're going to do is we're going to count this way, because that would be carbon 2 and carbon 3. So one name for this beast would be 1 ethyl, 3 hexyl benzene. See, because the ethyl's on carbon 1 and the benzene, the hexyl is on carbon 3. Or, right, since you skip one site, we're skipping one site, right? This would be meta ethyl hexyl benzene. Okay, I'll do another one of these examples, okay? Hopefully this is helping. All right, so let's do our benzene first. One. Okay, and let's say up here I put a C7H15. Right, that's a 7. Okay, and suppose here I put a C3H7. Okay. Well, again, let's name these things first. Let's see. Well, C7H15 is heptyl, 7-heptyl, and C3MEP, this is a propyl. Right? So again, H comes before P, so that would make this carbon, oopsie. Sorry. Get that little bit of red out. Okay. So that would make this carbon number 1. Okay. And it doesn't matter if I go count this way or I count this way. Either way, we're going to get 2, 3, 4. Right? So this is going to be on, propyl is going to be on carbon 4. So one name of this would be a 1-heptyl 4 propyl benzene. Okay, or since you skip 2 sites, skip 2 sites, this would be called para heptyl propyl benzene. Okay, we'll do another one. Okay, let's do another one of these. Okay, so I'll draw my benzene. All that matters is the relative position. Draw my benzene. All that matters is the relative position, okay? So here I'll put a F, oopsie, and here I'll put a C, come on, C8, H17. Okay, well, let's identify these things first, right? C8H17 is octyl. Oh, excuse me. Octyl. Come on, pen. I know you could work. Come on. There we go. And of course, this is a fluorine. Sorry, that is really not clear. Okay, I'll start again. All right, so this is a fluorine, as we know, just an F. I'm just writing everything down, fluorine. Okay. Again, my pen is getting tired, I think. So again, a fluorine. So we know F definitely comes before the O, so we would count this as site 1. Okay, I think we're going to count this way, right? Because we get 2. And oh, geez, I can't help it. It's just the pen's acting really strange. Okay. All right. So we're going to count up here, because if this is carbon 1, that would make one more try. I'm sorry. All right, so I'll finish this circle here in green. That's okay. All right, so again, this is carbon 1. This would be carbon 2. And so this would be carbon 3. If I counted the other way, that would be carbon 2, 3, 4. That would be carbon 5. So we're not going to count that way, right? So one name for this would be a 1-fluoro, right? And then we said count going up clockwise, then it would be a 3-octyl benzene. Okay, right? So now we know also, right? Or I don't know why my pen is doing this. Okay. Or, right? We can name it with the we're skipping one site, right? We're skipping one site. Skip one site. One site. right? So this would be meta. This would be meta fluoro octyl benzene. Okay, either 1-fluoro-3-octyl benzene or meta-fluoro-octyl benzene. Okay, equivalent. Okay, let me just show you one other thing. Well, two other things. So let's do this. Watch. There's my benzene. I'm going to put a CH3 here. And I will put a bromine here just to make this easy, okay? So we know that's methyl. Okay, we know CH3 is methyl. Okay. So we know clearly, right, bromine comes first, so that would make that carbon 1, right? So this would be a 1-bromo, because bromine comes alphabetically first, right? And then we have a 2-methyl benzene. Straightforward, easy. Or, right, they're next to each other. They're next to each other. Next to each other. Next to each other. When they're next to each other, we said that was ortho. So this would be called ortho bromo methyl benzene. Okay. Now, pay attention to this part, okay? Because what I just did, I think, is straightforward. There's no tricks, no tricks, no tricks. Okay, now watch what I'm going to do. I don't know if you remember. Well, you shouldn't remember because we only did it once. But if you remember before, we said that a methyl benzene, I'm going to do this up here. Now I'm going to erase that and try to make it a little neater, okay? Because that looks like someone on drugs. Okay, so again, forgive me for my artistic lacking here. Okay, so we said, again, one thing, it doesn't matter. We said CH3. We said this was methylbenzene. Methylbenzene. But we also said methylbenzene was the same as toluene, so we could call it toluene. Okay. Now, what makes this toluene is this methyl group. Methyl makes it toluene, okay? So now I'm going to redraw this picture that we have in blue, okay? So here's our benzene. Come on. And now on this here, we had CH3. Oh, dag nabbit. I'm sure it's me getting tired, so not the pen. I'm not going to blame technology for my failures. Okay, and here we have the bromine. Okay, now I want to call this methylbenzene. Okay, I'm going to call this thing methylbenzene. No, I don't want to call it methylbenzene. No, that's not what I want. I'm sorry. I want to call it toluene. We just did the methylbenzene, so I want to call this toluene. 10, really it's not me, toluene. Okay, now what makes this toluene? Why is it toluene? It's toluene. Come on. It's toluene because of the methyl. So if I define this to be toluene, then this methyl forces this. This now is carbon number 1. Okay? That means where I put this bromine here, this would be carbon number 2. So this thing would be named, watch this, 2-bromo-toluene. Because the bromine then is on carbon 2, because carbon 1 is the methyl that made this toluene. Or, right, we could use the next to each other. So this would be ortho bromo toluene. Okay. All right, we're going to do another example with this toluene, okay? I'll put the methyl here, CH3. And up here, I will put a C2H5, right? So we know that's ethyl, right? So we all know this is ethyl. So right away, I can say, all right, this is a 1-ethyl, 2, 3, a 4-methyl, 2, 3, a 4-methyl, right? That's just alphabetical, benzene. Okay. Or, right, since we skip 2 bonds, remember, there was that prefix of para. So this would be para ethyl methyl benzene. So these are both correct. Okay, absolutely. They're both equally correct. Nobody's better than the other. Or, now if I want to call this thing toluene, that forces this to be carbon 1, because that's what defines toluene. Okay, that means that this guy then is on carbon. It doesn't matter which we go, 2, 3, 4. Okay, so this would be a 4-ethyl toluene. Or, right, remember when you skip 2 bonds, it's para. So this would be para ethyl benzene. So we have 4 names for this. All of them are correct. Okay, I won't get into a bunch of other things that have different names. I just stick with toluene for you guys. Okay, so that's enough. All right, so we did two substitutions. All right, so now what I want to do, I want to do many substituted benzene. Poly substituted benzene. And here, we don't use para, ortho, or meta. We don't use that. We just number them. So you'll substituted benzene. Okay, so let me give you a couple of examples to give you the idea. And I think this is pretty straightforward. Okay, so Always we go alphabetically, so don't forget alphabetically. Alphabetically. Okay, so suppose I put a BR, and suppose I put a BR, and suppose I put a fluorine here. Okay, so there's three things. And clearly BR comes before F, right? So what I would do is, let's see, I think I would name this carbon 1, carbon 2, carbon 3, and carbon 4. So I think I would name this 1, 3, di-bromo. Remember, there's no para, ortho, or meta. Now we just numbered. So it's 1, 3, di-bromo, 4, fluorobenzene. I think that would give us the lowest combination. So the bromines are on 1 on 3, and the fluorine is on carbon 4. Okay, do another one. Poly substituted. I'll put C2H5. I'll put a C5H11, and here I'll put a C6H13. Okay, so let's see what we have. First, let's name them, right? Because we want to get all the names right. So we know this is ethyl, because we want to get all the names right. So we know this is ethyl. C5H11 is pentyl. C6H13 is hexyl. Right? So we know ethyl is going to come first. So this is going to be carbon 1. And it seems to me, 2, 3, 4. It seems to me I should count this way. Okay? So I think I get a 1 ethyl. Either way I count, clockwise or counterclockwise, it will be a 4 hexyl. Right? But if I count clockwise, then I get a 3 pentyl. So this would be carbon 2, carbon 3, carbon 4. If I went counterclockwise, it would be a 5 pentyl. So this is lower. And then this would be benzene. See, we just do it alphabetically. And then find which direction. So 1 ethyl, 4 hexyl, 3 pentyl, benzene. Okay, we'll do one more. And then your heads will really be saturated. Okay? Okay, so here we have 4 things on there, okay? Once again, we need to go alphabetically. So we have the bromines are good. We know, C8, H17 is what? That's octyl, right? Octyl. That's octyl. And C9H19 is nonyl. Okay, so it seems clear that I'm going to go this way. Count that as carbon 1. This would be carbon 2. This would be carbon 3. This would be carbon 4. And this would be carbon 5. Okay, so this is very simply, this is straightforward. 1, 2, right? There's 2 bromine, so it's di-bromine. bromo. All right, and then on carbon 5, N, N comes before O, so then we'd have a 5 nonyl and a 4 octyl, and that would be benzene. Okay. Okay. And we'll do one last little one, okay? C2H5, 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 C3H7. All right, let's see what we get with this thing, right? So we know C2H5, these are our old friend ethyl, right? There's an ethyl. There's an ethyl. Oh, there's an ethyl. And then finally, MEP, this is a propyl. Okay, and it seems clear, I think. 1, 2, 3, 4. 1. I think we're going to count with this 1, carbon 2, and we got to keep going. Carbon 3, carbon 4, and carbon 5. So it looks like we have a 1, 2, 4 triethyl, triethyl, and then what is that? A 5 propyl. Benzene. You double check, see if you get a lower number, but I think that's the way I would count. I would count going this way, from starting from the bottom and then going this way. Okay. I could be in error, but you check. All right. I hope this helps a little bit. Study hard. Good luck. And that's it.